Nature of EM radiation. EM stands for electromagnetic radiation. If you look, if you watch a colony of ants walking up the wall, they look like a thin, continuous black line. But as you look closer, you see that the line is made up of thousands of separated black ants. Light and all other types of electromagnetic radiation seem like a continuous wave at first, but when one performs experiments with light, one can notice that the light can have both wave and particle-like properties. Just like the individual atoms, light can also be made up of individual bundles of energy or a quantum of light. So they've made us an example of arts. So they said light is like a continuous wave at first, but when you perform an experiment, you will see some of the energy bundles, some of individual bundles of energy. If you do an experiment with light, one can notice the light can be both wave and particle-like properties. Just like individual arts, light can also be made up of individual bundles, energy, or quantum of light. Let's say this is a light. We are seeing the light in our naked, maybe naked eyes. We will see the wave of the light. We'll see the wave of a light. But once we make an experiment of finding what is in the light, when we get closer by using an experiment tools, we'll see that a light has individual bundles of energy or a quantum of light. Just like the ants, when you look closer, you see that they're made of thousands of separated black ants. But when you do not look actually closer, you look far away, you see the waves of of the light. So they're called wave-like properties, and particle-like properties are when you look closer to the light. Light has both wave-like and particle-like properties. With particle duality, they're called wave-particle duality, but only shows one or the other. Depending on the kind of experiment we perform, a wave-type experiment shows the wave nature, and a particle type experiment shows the particle nature. One cannot taste the wave and the particle nature at the same time. A particle of a light is called a photon. So a particle of the light, it is called a photon. Just like a one small ant is called what? It's called a small. So just like when you look, it's gonna be called a particle of light. One small ant you see is gonna be called a one particle of it, and so particle of light is called a photon. Definition: photon. A photon is a quantum energy packet of a light. It's energy packet of a light. You can say energy packet of a light or a quantum. Fields. Accelerating charges emit electromagnetic waves. So accelerating charges emit electromagnetic waves. So they release a electromagnetic wave. So when a charge is accelerating, it will release an electromagnetic waves. Let's say, for example, a magnet. We know a magnet has a charge, a positive charge and a negative charge. When it accelerates, it will release electromagnetic waves. A change electric field generates a magnetic field. A change in electric field generates magnetic field. And a changing magnetic field generate electric field. It's vice versa. When when a electric field changes, it will generate a magnetic field. While a magnetic field changes, it will generate a electric field. This is principle behind the propagation of electromagnetic waves. So this is the principle behind the propagation of electromagnetic waves. So a change in the electric field will generate a magnetic field, while a change in magnetic field will generate electric field. So the fields are like a vice versa thing. We have in the field we have electric field, we have magnetic fields. So this is a principle behind propagation of electromagnetic waves. Electromagnetic waves in EMF wave, EM waves. So propagation refers to a way something travels, so or spread from point to another. It's a way where is a principle behind the traveling of the electromagnetic waves, or it's a principle behind of spreading from one point to another of electromagnetic waves. Because electromagnetic waves, unlike sound waves, do not need a medium to travel through. You have to note that. Electromagnetic waves, unlike sound waves, EM waves does not need a medium to travel through, but a sound wave will require a medium to travel through. It will require a substance, it will require a surface in order to pass through. So we are moving on to EM waves propagate. So how, like we're going to talk about EM waves propagate. EM waves propagate when electric field oscillating in one plane producing a magnetic field oscillating in a plane right angles to it. So EM waves propagate. So propagates refer to a way something travels, and oscillation is a repeated back forth motion. Think of it like a stream. So like we when we say oscillation, we're gonna think about it like a stream. A stream. Okay, EMF waves will travel when electric field stream in one plane produces a magnetic field stream in a plane at right angles to it, which produces a string electric field and so on. The travel of electromagnetic waves can be described as mutual. Um, the magnetic fields can be described as the can be described as a mutual induction. The changing electric field is responsible for inducing the changing of electric field. So we have talked about electric field, like we say that a changing in electric field will generate what? Will generate a magnetic field. So a changing in electric field will generate a what? A magnetic field is responsible for inducing the magnetic field and vice versa. So it is responsible for inducing the magnetic field and vice versa. So this electric field, if it changes, it will what? It will, if electric field changes, it will generate magnetic field. So let's let me describe this EM waves. EM waves, they say it spread when an electric field string in one plane producing a magnetic field. So, in order for this EMF to move or to spread out, you have to wait for electric field to actually swing in one plane. So EMF, in order for it to spread out or to travel, you'll have to wait for what? For electric field to swing. For electric field to actually swing in one plane produces a magnetic field. So you have to wait for this electric field to swing and produces a magnetic field swinging in a plane at 10 right angles of it. So let's say, for example, this is my let me just take this penny. Just this is my EM. So this will when this electric field um swing in one plane, producing magnetic magnetic field swinging at a right angle. Okay, you gotta think about it. It is one of my example. A change in electric field is responsible for inducing the magnetic field and vice versa. It's very responsible for this magnetic field, for inducing this magnetic field.